Hello everyone, welcome to our video. Taylan Gönenli and I, Elif Şahin, made a presentation about relation of acoustics and audiology, and now we are going to present it to you. These are the includings of our presentation. I'm going to present audiology and acoustics for audiologists, and Taylan Gönenli will present acoustics of speech and hearing and acoustic trauma. So let's start with what is audiology and acoustics. Audiology is a branch of science that focuses on hearing and balance disorders. Acoustics is a branch of science deals with the study of sound and its behavior in different environments. Let's take a look at audiological terminology, which is nearly same as basics of acoustics. It is essential for an audiologist to have a working knowledge of acoustics. Acoustics is the study of science based on sounds. As the sound waves are made up by vibrations, there are some terms which are used both in audiology and acoustics. Sound, form of energy produced by a vibrating object. Compression, region in a longitudinal wave, particles of medium is close to each other. Rarefaction, region in a longitudinal wave, particles of medium are far to each other. Wavelength, the time duration of one complete cycle. Frequency, number of sound waves per second. Frequency range in normal hearing is between 20 and 20,000 Hz. Speech frequencies are 500, 1000 and 2000 Hz. In this slide, the figure 6 illustrates the speech banana, which is a graph that shows the frequency range of each phoneme. Sound propagation and hearing. Sound transmission. How sound travels from the environment to the auditory system, illustrated in figure 7. Room acoustics. Impact of environment on sound quality, critical for hearing aid fitting and speech comprehension. Reverberation. Prolongation of sound, excessive reverberation can impair speech understanding. Importance of acoustics in audiology. In audiology, acoustic principles form the foundation of hearing health. The diagnosis, treatment, and management of hearing loss are closely linked to understanding and applying acoustics. Therefore, the importance of acoustics in audiological practice is significant, and hearing health professionals should effectively utilize these acoustic principles. These are the whole topics that explains importance of acoustics in audiology. Physiology of hearing and acoustics. When the sound waves enter the outer ear, they cause the eardrum vibrate. These vibrations are then transmitted to the cochlea. The cochlea converts the mechanical energy of sound into neural impulses, which are then conveyed to the brain as auditory information. Assessments and treatments for hearing health rely on understanding these acoustic processes. On this slide, figure 8 illustrates the hearing process on human body. Hearing loss and acoustics. Hearing loss can stem from various causes, often associated with acoustic factors. Factors such as noisy environments, aging, genetic predispositions, and trauma to the auditory system can lead to the hearing loss. Audiologists use acoustic tests to determine the degree of hearing loss. Imagine 9. Graph about the degree of hearing loss according to the decibel and speakers or listeners' distance. Hearing devices and acoustics. Hearing devices provide crucial support for individuals experiencing hearing loss. These devices amplify external sounds and enhance vibration transmit to the inner ear based on acoustic principles. Audiologists utilize acoustic principles to properly adjust and utilize hearing devices. Imagine 10 shows hearing aid components. Design. Amplify sound to improve hearing. Digital signal processing, DSP. Filters and adjust sound for clarity and comfort, illustrated on figure 11. Feedback management. Uses principles of acoustics to minimize whistling and other unwanted sounds. Rehabilitation and acoustics. Rehabilitation for individuals with hearing loss takes into account acoustic factors. Rehabilitation methods such as speech therapy and auditory training are designed considering the degree and type of hearing loss. In this process, acoustic compatibility and individual needs are paramount importance.
Acoustics of speech and hearing. Understanding the acoustics of speech and hearing is essential for various fields such as audiology, linguistics, communication disorders, psychoacoustics, and speech-language pathology. It helps in diagnosing and treating speech and hearing impairments, designing better communication technologies, and advancing our understanding of human communication processes. Speech production. Phonation. Sound is produced in the larynx, voice box, through the vibration of the vocal folds. The pitch of the sound is determined by the rate of vibration. Articulation. The vocal tract, including the mouth, throat, and nasal passage, shapes the sound produced by the vocal folds into recognizable speech sounds, phonemes. Movements of the tongue, lips, and other articulators alter the resonant characteristics of the vocal tract, producing different speech sounds. Resonance. The resonant frequencies of the vocal tract determine the characteristics, timbre, or quality of a person's voice and influence the specific frequencies emphasized in speech sounds. Requirements for speech production: respiration, phonation, articulation, resonance. Sound. Frequency. Frequency refers to the number of oscillations per second and is perceived as pitch. Higher frequencies correspond to higher pitches, while lower frequencies correspond to lower pitches. Amplitude. Amplitude refers to the magnitude of the sound wave and is perceived as loudness. Greater amplitude corresponds to louder sounds. Spectrum. The spectrum of a sound wave describes the distribution of energy across different frequencies. Speech sounds have specific spectral characteristics that help distinguish one phoneme from another. Acoustic trauma. Acoustic trauma refers to a type of injury to the auditory system caused by exposure to extremely loud sounds or sustained exposure to moderately loud sounds over time. This trauma can result in temporary or permanent damage to the structures of the inner ear, leading to hearing loss, tinnitus, ringing in the ears, or other auditory problems.